All right, so what we're going to talk about today is basically rebuilding replication on larger databases. Now, when I'm talking larger databases, I'm talking terabyte plus. So databases of size. So real world experience. My remote mouse died, so you'll see me walking back and forth a few times. So what we're going to do is we're going to go through a little introduction. I was supposed to have a co-speaker, but work-related items hit him and he couldn't come. So we're going to talk about some of the background that we faced, the environment that we were in. Okay, this is not environment specific, it's technology specific on how we did things, but it's applicable to other environments. What we had to solve, so what our big problems were, mostly the clock and trying to get things done in a realistic time frame. What options we had available, supported and not. We had to look at everything. What we did, any risks that we saw within the process and how we tried to mitigate those. What our results were, right? How long did it actually take us to do this? And then we'll have some questions. So my co-presenter was Mike Beresford. It's right here, Mr. Invisible today. He's a vice president at Freedom Mortgage, same company that Brian Clark here in the front's with. So a large mortgage underwriting company. So, volumes of financial transactions, complex infrastructure. And then, myself up here. I work in our professional services side. Many of you have seen me, many of you have had me at your shop, so I've been around a while. So what we had was we were trying to upgrade from 10.2b to 11.7. Okay, nothing new there. But once you do that type of an upgrade, you're going to be breaking your replication. You're going to be doing a number of other things because of the way we had everything built. So we have many business testers involved because we're financial services. So everything has to be tested after a conversion. A lot of moving parts, a lot of interconnects between different systems. So we're on IBM hardware, mostly virtualized, but big P8 hardware, SAN, everything else, and this was all in the same data center. So I've already had that question from a couple of other folks who knew this topic was coming and hit me last night. So our database, about 1.2 terabytes. It's about 1.4 pre-allocated on disk right now. So we had an 8 gigabyte BI, so decent size BI file system, 150 after image extents. We have enough after image extents that if we cannot replicate, we can still keep our database going with AI for between 3 and 7 days, depending on activity. So a lot of after image files in process. We are using type 2 storage, and we do use a secondary buffer pool for our control tables. So, a little bit of DBA work has gone into this process. We have a single source database and 2 replication targets, and each of my replication targets has after image running. So that way, if we ever have to fail over, whichever machine fails over to, AI is available, and we can go to either of the 2 targets depending. Now, the business model they have is the production system has no SQL connectivity. We do not want anybody to accidentally insert records through SQL into the production system without firing the business logic that exists in the OpenEdge side. So all of their reporting, all of their queries, all of their extracts, all go against one of the replication target databases. So now you can start to see where the complexity of this comes in place when we have to get testers involved. Because if I don't have my replication targets up and running, they can't test full suite. So, yes?
These 2 replication targets are in the same data center?
Yes.
So everything is in the same data center?
Yes. Different racks, different everything else. So, the hardware is isolated, but yes, it's the same physical center. We have a secondary center in their head office area, which is up in New Jersey. This is based out of Indianapolis area. And we do keep that in sync, but it is more of a, I'm not going to say a cold standby, but definitely a semi-warm. If we had to move things over, we could do it. There would be some steps involved, but like any failover or business resumption, there's a lot of steps involved with things. You can't just automatically flip things because of, simple things like DNS aliases, interconnectivity points, all of that nice fun stuff that people have out there. So we have a V7000 array, which is a decent piece of disk hardware, but realistically, it's what we call a tiered storage. So it has flash at the start. So most SANs have this type of capability now. So, most used areas stay in the flash RAM or solid state if it's up there. And then as it becomes less active, it goes down into slower disks and slower disks. So that's common with most. And these SANs run on RAID 6. So, poor old Gus, if he was here, would be having a hissy fit and his blood vessel would be going up the center of his head right now because I said RAID, and it's not RAID 1. All of our servers are Power 8s, so current technology with the servers. And we're running AIX 7.1. So to make life easy for all you folks, I saw a couple of cameras coming up. All of these presentations will be available after the conference. You're also hearing me speak through the mic. The recording will be sent with that as well. So everything is in sync. So you don't have to worry about, capture this to prove that I was here. That's when you go downstairs into the booth and you see that big blue chair there and you get your picture there. So nothing quite says Florida like a, teal blue chair, inflatable balloons and everything else. I did my plug for those guys now. So the problem we had, the clock. We needed to get this done in a very short time frame because our database is large. We had to rebuild the 2 replication targets. We had to go over everything. We had to do our internal checks, make sure everything works first before we even can allow other systems users to verify that their systems can talk to us before we can release it to the business to test. So, there's only so many hours in a short weekend. Yes. What the question was is our replication targets were in sync. Yes, they are. They have to be. So, like I said before, we need everything up and running. So the targets have to be available because of that, all that SQL connectivity, and we also want to make sure that our throughput is still going effectively. Traditional rebuild options, aka the book level supported ones, took a long time. We tested a lot of stuff. So we had to come around some things. So our options, right? Get everything done. Do a progress backup, do a progress restore, do your incrementals, do whatever. When we tested all that, our times were unacceptable to the business is a nice way of saying it. We had other choice words thrown at us, but let's just go with unacceptable to the business. So we tried some things. How long did it take to do backup to disk? It took 3 hours for our database using a progress backup. It hurt, and then we had to worry about, now that we have it on disk, we have to copy it to the target systems and then restore from those. So we were looking at somewhere between 5 and 7 hours elapsed time to get everything done. That hurts. Some of us that live the DBA life and all that type of things, we're used to staying up all night when we have to do these things. We still don't like it. And then we had some hardware options. We look at the option. The first option we had, what about an operating system multi-threaded copy? I'm going to copy each of my extents so that I can balance my load across my network and everything else and just push it over there as fast as I can. It was still 3.5 hours. Better than 7. Now, the issues that we had is, let's face it, if we do a standard progress backup and restore, if that backup has a problem, we have to restore again. That's another 2 hours that we would lose. If the transfer had an issue, there's a lot of moving parts that we have to worry about in this. With the OS copy, as soon as we try to start a database, if one of those extents had a problem copying across, my database would have different timestamps in the header blocks. AKA recopy it again. Or do some, funky, highly unsupported magic underneath the scenes. The other option we had was using the storage array snapshot technology. And most storage arrays support snapshots. Even Amazon and all those guys have it. It's nothing new. The fact that we had storage, like tiered storage with the high-speed disk and everything else, made it an option for us. Again, a lot of testing and a lot of work up front. So what we did for the process. First, we stopped everything, right? You want all your progress processes down. You want everybody out of the system, all that nice fun stuff. Same as you would for any other upgrade. Now, at that point, we converted our main database. Now, if you run the convert 1011, it's supposed to do everything, be fat, dumb, and happy when it's done, right? We had to disable replication, disable AI, do all that type of stuff. But one thing that we found during some of our testing is even though we did that, we still had to do an update VSTs after. Don't know why, but we found that during this process, if we didn't force that update of the VSTs when we were doing the copy that we were trying to do, some things may not have been flushed through the disk system. And it's one of these things that if you're trying something that may be, well, let's say highly unsupported or marginal, make sure you test everything end to end and a number of times. And we did. At that point, we took a snapshot of our source database. When you use snapshot technology, what it does is it basically takes a copy of your disk and makes it into new LUNs, so logical units, or if you want to think of it, mount points for file systems. So now we have a new snapshot of our full database. So I have a point-in-time copy of this thing. So what do we do at this point? Well, this is called paranoia time, yes. Snapshot is about 10 seconds. Takes about 20 minutes behind the scenes for the disks to fully sync everything through. But at the time you do your snapshot, you have full read-write capability on that target. So at this point, we've got a snapshot. Yeah? We're going to go through that. Well, of course, we always do full backups. We had a snapshot before the hand. Like this happened after our normal down window where we do a master snap. And then what we did here is after we did the source one is when I have this as new LUNs, I took my existing master right here and we basically unmounted those file systems and mounted the new ones. Basically, I mounted the snapshot as my active file system. So I had my master that I used for everything basically offline. So here's my converted database point-in-time snapshot. I had a snapshot of pre-convert, and on my targets, you'll see in a second what we did for those ones. So now that I've exposed everything, right, I have to re-enable all my AIs and AI archiver, right, because I've converted it, I have to rebuild it. It's a standard process for, rebuilding a replication system. And then we start our targets and we're good, right? Always start the target before you start the source, stop the source before you stop the targets. The way I explain it to a lot of folks is think about, being married. If your wife starts talking, you better be there listening, and you better not stop listening until she stops talking. It's the same thing with a replication set. So, the concepts of snapshots. In this case, it was an IBM array utility, but it's out there with a number of them, a number of NASs, a number of storage arrays support a snapshot technology. It is a point-in-time full copy of your system. And the nice thing is you have immediate read-write access to that one. While it's copying everything behind the scenes in the array, you don't care. You can start playing with those disks and mount them, make them live, do whatever. A lot of folks do, if they have databases of size, will do a snapshot of their disk at night and then remount it somewhere and do a progress backup and fire that off to tape. A lot of folks have to. So we had our original master. So we did our source snapshot, right? This is our recovery points, if you want to think of it that way. We had our targets, our primary and secondary target. We basically unmounted those file systems. That's my point in time recovery right there. I have my master database and my 2 targets, point in time. So at that point, we do a couple of snapshots from that first snapshot. So here's my convert. So here's what I'm going to make to my 2 targets. Remember I said it makes them as new LUNs. So I can mount those LUNs on the other hardware as the new file systems. And then from there, we go across, do the standard stuff that we would do within any replication, transition it from source to target. So now I have my 2 targets, I have my source, and then I can actually go through, start everything up. So some of the risks that we looked at. What happens, when bad things happen to good people. So if we had a failure, we lost a database. Can happen. We hope it doesn't. That's when a lot of bad people, get upset. But if it happens in the first 24 hours, because we did not do a progress backup at this point, our AIs would not be in sync. We knew this. It was a risk that we were willing to accept based on, we had 2 targets up and running. If we lost, the only thing that would really kill us is if our data center went up. Right? We may have to start over. If we lost everything, we would have to start over. But that would have meant that we would have had to lose our source system and our 2 targets. Now, realistically, in the event of a power failure or anything like that, our whole data center would be down and a number of other systems would be down as well. So there's a lot more activity rather than having to worry about, can we transition a progress database? But if our server started dying or our data center or our SAN potentially, then, we had a risk because everything is in one center. But we had options. Depending on the level of, if you want to think of it, disaster or business impact, we could just go back and start redoing snapshots. If I lost my target systems, I could re-snap from my source and then transition to a target system, and that one would be back up. Remember, snapshots, as soon as I make them, are now available to be presented to a target system. I transition them back over from source to target, and everything is fine. Now, the third point on there is the big one. We were taking a calculated risk. We knew this. Right? We were using operating system utilities. We were using, ProQuiets. We were using everything else out there to try to make a deadline. We went through all the risks. We went through a lot of testing. The big thing was the testing. Now, I'm not saying, this was real easy to set up and do everything else. There was a lot of storage array work that the engineers did to make sure that our snapshots would happen on the high-speed array, would do a lot of the other things. And we tested this a number of times, not just with the sports database. We started with the sports database. Why? Because it's small and it's easy to do. I can do that on a Linux box and say, does this even work? How long does it take? That was some of our testing and proof of concept, if you will. We used smaller databases. And then we grew up in databases, and then we started going on to production-grade hardware and doing the same type of testing until we got to the full volume database tests. You have to. Anytime that you're doing full upgrades and you have everything else involved, there's a lot of testing.
So just one question.
Yeah.
In traditional method, we generally sync target by taking online backup with replication option.
Right.
And once we
The REPL target create, yes.
Then syncs.
Mm-hmm.
But here you are just taking snapshot of the source
And flipping it.
Target now syncs to the source back.
Yeah.
What did you checking?
Well, what happens is when you take that snapshot of that source database, it's set as a source. right? So basically you're copying that source database and throwing it over on the target box. When you use a pro-util command called, transition that to a target, right? So if you're following not the progress restore, when you do the REPL target creation, it does a bunch of other stuff behind the scenes when it does the restore. But through the pro-util commands, you can actually go through and say, enable this one, transition it from a source to a target.
Oh, okay, so you are saying transition, so that becomes source.
We leave our source as a source, but when we make our copies, we transition each of those target ones that we just put over on the target boxes as a target system. That is available in 10.2b and above to transition to a target. That's always been there. But the two active targets and stuff like that with, the failovers between those ones and everything else was an 11 option. Now our properties, our replication properties file is a common replication properties file for all. So I have one properties file that has everything from my source and my two targets. So that's all defined in the one file. So that's also part of when we snapped everything across, that went across in those file systems. So I already had my REPL target, my database name .repl.properties file over there. And when we turned everything off the first time, right, we hadn't started our database. We didn't have that recovery file yet. So that's the other thing you have to watch for is when you do these copies, make sure that you don't have a REPL.recovery, database name .repl.recovery, because that's the binary file that tells the source and the targets where they were in sync, what the last block copied, all that type of stuff was. If you have that on your target system and you're bringing it up for the first time, it has a little bit of a hissy fit because it thinks that I've already been in sync once, but things aren't adding up now, and it'll throw a number of wonderful errors in your logs.
So transitions to targets is a trick basically. Okay.
It's not a trick, it's a way we used to do it. When replication first came out, well, back in history when Open Edge replication first came out, we didn't have that REPL target creation option on a backup. Right? You used to have to do a full pro backup of the database, bring it over, you transition this one to a source, do an incremental backup, restore that over there, and then flip the switch from this one from a source to a target. That was the old way of doing it, before the REPL target create flag. So basically we went back a step, but changed some of the process in between by using hardware options instead of, dumping to disk and moving things across. So like I said, our SAN guys spent a lot of time on this, right? Because we were testing, and if we found things to be slow, they were saying, okay, how can we make sure that the database stays in flash when those copies happen? And I think they spent somewhere between, 2 and 5 days overall in the process, looking at SAN and configuration and optimizing all that stuff during the testing cycles. Overall, did it probably take us, elapsed clock time of man effort and everything else longer than doing it the traditional way? Yeah. Had to, because we had so much testing, we had so much configuration and everything else up front, so that when the actual event of making this happened, we knew what happened, we knew our time frames. We had ballpark time frames already spread out, so we had a nice Excel spreadsheet we shared with project management, and when we went through things, they knew approximately how long every step would be when we were on the conference bridge and everything else. So it's like, okay, we're at this step now, we're at this step now, we're doing this, we're doing this, we're doing this. And it was, a huge coordination effort. Project management does have a purpose, other than just bringing coffee and donuts. But we like it when they do that too.
A little bit more steps.
Mm-hmm. Well, when you say more steps, you mean for the SAN itself?
No, I mean the transition part and all that.
What?
How you transition to a target and then you transition back.
Well, we didn't have to transition back. So what you do is you set your source and leave your source as a source. Once we make that copy over there, the copy that's on the target box gets transitioned to a target. So when I start that up, it knows it's in a target mode, right? On any database that's in a replication set, there are underscore tables, the underscore REPL, blah, blah, blah tables. And they will tell you if you're in a source database, if you're in a target database, if you're in read-only mode, whatever. There's a lot of information you can get on those VSTs. The replication process understands that. It's almost like the guys who wrote that knew something about the database engine. But we're not going to hold them to that. Right? So the big thing about testing whenever you're doing something that is out of the book documented ways of doing things is always critical. I can't stress that enough. You got to test it, you got to make sure you know it for multiple reasons. One, to make sure that the process works, and going through it at each step and knowing how long everything takes, and if there's something you can tune or tweak or whatever. Because as we were going through this, we had to justify and say, well, this is going to take this long, this is going to take this long. Is that acceptable? Because we also had to schedule a significant number of business users to be able to come in and do their testing after we did our process as OpenEdge and getting the application up, and all the rest of the IT folks getting all the ancillary systems like their web setup, all the downstream data feeds and everything else that they use in their daily application set. It's not just one application. This just happens to be the main system of record for a lot of it. So we had to figure out the timings of our stuff so we could coordinate with IT folks so that they could do their next step. Like they could stage things like the ODBC driver, for example, and things like that. But they couldn't test anything until we had our system up. So the coordination of all that timing, the only way we can get that was doing testing, and a number of testing. The big thing with testing anything like this, especially when you're going through anything, is documenting it. What did we do? What steps did we do? How long did it take? Whether it worked or not. So that way, let's face it, business happens. We have to take a break, we have to come back, fix something else, come back, and then we test again, right? What did we do? How did we prove this? Especially when you have to go, to the senior business folks and say, here's the process we followed, here's everything we did, and here's our recommendations. Because ultimately, when you're using anything that's out of the ordinary or even having significant downtime, that's a business decision on risk. What options we have, and then they have to say, yes, we're willing to accept a 36-hour downtime. Ours was nowhere near that. So the big thing when you're doing things with arrays or anything on disk or with a database is make sure you reset things, right? Disk cache is huge. You run a query. Okay, you have this long-running report that runs at night and takes 3 hours. Well, you do a pre-stage of that query, run it right before that. How long does that thing take? Your pre-stage query may take 3 hours between 4 o'clock and 7 o'clock at night, but then when your report runs at night, what's in the buffer pool? What's in your disk cache? That report runs lightning fast.
What did you do to make sure that was a flash memory on the disk? Did you do the backup?
No. It's a setting that was available within the SAN because we could specify certain LUNs having higher priority. So what we did is we said the main database, those LUNs, because they're also highly used, and we were, basically we had everything down, we just upgraded the database. So all of those database blocks were the currently most used. But the SAN guys went through and said, these specific LUNs, which happen to be the ones for our database, are tier 1. So you can actually allocate certain things and override the SAN in some plans. But big things is always retry. Never just do one test and say, yes, we got our timings down, it's great. Right? Standard testing process, at least 3. With a full flush in between each one. Because, you could have a good point in a disk, you could have a bad point in a disk. Try to get 3 points with common time frames. You're not going to hit dead onto the second on each one. So the results, right? First one, source database converted in under 5 minutes. Standard pro util convert, right? We're in the progress shirt. I have to tell you it happened in less than 5 minutes. Realistically, happened in about, 45 seconds. But then we ran the update VSTs, which took us about another minute. So we were done in about 3 minutes. Then we copied our flash copies. because of the array and everything else, those completed physically on the hardware in under 20 minutes. Didn't bother me, didn't impact any of my times. Because as soon as those did their snapshot, I was able to move them across and start working on them. So the fact that that took 20 minutes, that's just hardware time to say, yeah, everything is perfectly in sync. Didn't affect our process. We had our source and targets built from start to finish in under 40 minutes. And that include checkpoints between. And when I say they were built and configured, that also meant we started the things and we saw that wonderful, beautiful message in both of them saying your source and target databases are synchronized. And there was much rejoicing. All right? So, while it's not a textbook process, we proved it worked. Again, we went through a lot of testing. But since this is not the documented and approved way of doing things, don't call tech support. Because if you call tech support and said, Rob said that we did this at another customer and it works, they're going to go, they have to give you the standards. We went out of the box. We had to because of our time frames. We didn't have a choice. All right? We've all been there. We've all looked at, larger databases and going like, yeah, I need to rebuild a server or I need to do this or move things across and it's going to take a long time.
How did you go on the traditional way? What was your estimated time?
If we would have done the backup, restore, and copies in between, it would have been 7 hours to get the initial target up and running from start to finish. We timed it at about 3.5 hours for the first progress backup, about 2 to 2.5 hours to copy those files across to the target system, and then another 2 hours to do the progress restore. And then, of course, we would have had to transition and stuff like that after.
But is there any way we can do, ahead of time, pull back up and move at the target, and then the target is really just take incremental backup?
Not really, because we had to convert as well. Remember, we went from 10 to 11. If I was staying on 11 and I was just trying to rebuild my targets, I have a lot more options because I don't have to do that disable AI archiver, disable replication because I'm changing fundamentals of the system and doing a version change. If I was just doing something like schema change and I needed to rebuild my targets because I was moving them to different servers, that's a whole different story. Because then, yes, I could do my full backup, restore that over there whenever, do my incremental, as long as it's within the time frame of my full backup, that incremental then goes across, right? And as soon as I bring that up, anything that's in the AI archives will start synchronizing across. So any schema changes, anything else like that would go across and go through as the AI notes get processed. So there's a little bit of a difference in that world. Now, the other difference here that I had one person ask me last night is, can I do this if I'm porting to different hardware? Well, if that different hardware supports a standard progress backup restore with the same architecture, yes, but I can't go from AIX to Linux. But if I had something like HP UX and I was going to Sun Solaris, for example, they're binary compatible on their stuff, so yes, I could. Not highly recommended, but there's ways around things. But we stayed on the same hardware, same platforms. We just had to move things across.
I missed the first few minutes. How big was the database?
1.2 terabytes. The nice thing about this application is the main database itself is 1.2 terabytes, but as data ages off and gets processed through business functions, it gets archived off as well. We weren't concerned about the archive database at this point or any of the other ancillary stuff. We'd already ported across, 2 or 3 systems before that of applications that we'd already done. So we were basically staging things going up forward to version 11. So we'd done all the ancillary applications and now we were on the main system. Yeah.
Was there anything that surprised you or was it like a gotcha?
Although we tested it at between 2:30 and 4 o'clock in the morning, seeing it going through that fast, yeah, you slow down and start double checking everything again before you start checking a switch. Was there a big aha moment? Not really. It was surprising when we were doing our initial tests, when we were going through things of, how slow this process is versus this one. And we even tried, okay, what if I do my progress backup to a disk file and then snapshot that disk file and move that across? And just, the speed of the backup versus the restore on the target systems and everything else. But most of our ahas were business unit related. Because realistically, okay, I can get my stuff done. I'm happy. I'm out. But we had to stay online for the other systems to all come up and synchronize and do their stuff that connected to our stuff as well before we could even say, I can get some sleep. So we were up till 7 in the morning because everybody else took 4 hours. Just because, other technologies like .NET and Java and crap and Oracle. My favorite stuff, yes.
What's the justification for having 150x that side?
They had a business model that said that in the case of any of my targets going down, I want to be able to store enough information in my AIs for an extended period. And that was like a long weekend or...
You have archival runners, you have all those things files. So what's the point of having so many active files?
If I fill up my file system where my AI archives go, then it starts locking AIs because it can't archive. It will still archive. Your AI file will still stay locked though. Remember, the AI files have multiple stages, right? They have it as, empty, busy, full, and locked, and archived. Archived is a special flavor of locked. It means it's archived it off, but it hasn't replicated all those notes to the target systems yet. So it will still stay as a locked AI that you can't reuse. So, yeah, a lot of AIs. We don't use AI arcing for full. We flip them when they're full, and we go through a lot. There's a lot of online processing and everything else that spins through these things. Mm-hmm. Yeah. Yeah, very much. And they're bigger than 1 meg. Yeah, we have a separate file system that's just nothing for the AI archiver logs. So that way we have alerts on those.
Is the number of active areas having
No. Type 2 areas are nice because you can separate things out by records per block. You can tweak things for blocks per cluster. This is the overall size of the database. Now, we have a couple of areas that are, significant. If you take a look at your database, everybody has a database that's got 3 to 5 tables that are substantially larger than everything else. They're usually in their own type 2 area. The indexes for those are probably in, or should be in their own area, right? Because if you go through with all that type of stuff, you have type 2 areas, and when you make a type 2 data area, you have an index area associated with those, so you can, really cheat if you're doing index rebuilds by truncating your index area, and all those index nodes are gone, so phase 1 of index rebuild is complete in like very short time frame. But yeah, so that was the fun that we had. And I think we're down to, questions. Not bad, we have about 5 minutes left. But we've been open with most questions, so if anybody has anything else, otherwise, thank you for coming. Please fill out the surveys, come down to the booths, have some fun down there, take pictures in that big blue chair. The girls down there like it when people come down there and take a nice happy picture, like, gotta have fun with all that. You're here in Florida, make it fun.
Do you think that the gains in efficiency that you saw with scale to multiple databases versus one very large database?
Yeah. Because realistically, I don't care if your database is, terabytes or 20 gigs. We still have the same issues that everybody faces, especially with a lot of partners that have, a bunch of people out there with the smaller databases. You want to upgrade and roll those upgrades through everybody. It's still going to take some time.
I just didn't know if some of the steps seem like they're manual steps and spread that across doing those
Mm-hmm.
10 times versus once.
Script them.
Lose some.
At that point, you know, if you're going to start doing things like that, like QAD or some of the bigger partners and stuff, they script everything. They'll do it the first time manually. They'll test it, make sure it works. Then they'll script it and start making, you know, pass parameters into it so that they can say, okay, run this now for this customer instance and custom, you know, all the way through.
And do you see anything in what you did here that would be dramatically different going 11 to 12 versus 10 to 11?
Nope. Same process for rebuilding. You know, 12 hasn't changed any of that. And eventually, when we do go to 12, we'll probably use something very similar. We have a lot of other things to worry about first when we, you know, try to get to 12. You know, moving away from classic app server into PaaS and getting that fully stood up and tested and everything in the environment around all that. And, you know, it's a financial services company. They're not going to go 12.0 because any .0 release you don't do. And realistically, it took us a fair bit of time to go from 10 to 11. All right, that was a big jump, 10 to 11.6 or 11.7.3. So it was a few years that elapsed between that. So
when you do this upgrade from 10 to 11, the existing target will automatically give up, right?
Mm-hmm.
So you stop.
right, because when you're doing the version change, you're actually going to have to break replication because you can't do. You cannot run the convert utility if you have AIs or replication enabled on your source database. You have to actually turn them off. It will tell you it cannot run on a database that has AI or replication, depending on which one it sees first. Usually I think it sees AI first, then it'll say, oh, this is enabled as a source, you can't do that. And then when you turn that off, then it, you know, convert utility runs really quick. So thank you all for coming.